Today, we are very lucky to be joined by Megan Brown, who is working with Open on the Liberia Forestry Climate Change Monitoring Project. She is in her third year of undergraduate school at the University of Maryland, studying atmospheric and oceanic sciences, and is currently working on two research projects within the department. The first is working in the Environmental Monitoring Lab, where she studies carbon sequestration and carbon capture and storage. The other is with a professor in the department studying the planetary boundary layer over mesoscale ocean eddies. Thank you so much for being here, Megan. We're lucky to have you.
Yeah, thank you so much for having me, Syra. I'm honored to be here.
Okay, so my first question is just tell us, there's a lot of big words in there. Tell us a little bit more about your research and what it entails.
Okay, so I'll start with carbon sequestration and carbon capture and storage, since that's what the Open project is really about. So basically, carbon sequestration is like when plants uptake carbon, that's sequestration. So basically like the uptake of carbon, or when the ocean absorbs it, like the downtake of carbon. Basically taking carbon out of the atmosphere is what that is. So what we're really working on is trying to find a way to get the carbon out of the atmosphere and kind of put it in a like container, a storage container, not like a storage container, but the best way to visualize it would be like a container to kind of hold that carbon and bury it so it doesn't go into the atmosphere again. So we're looking at biomass, which is like dead tree matter, and kind of storing that in a container where it will not leak out into the atmosphere and burying that under the ground. That's the like wood carbon capture and storage project. But for Liberia, I'm working on coming up with classes about carbon sequestration, and I'm very excited about that. I think it's an amazing opportunity that we get to work on creating classes, because as a student, I really think that you're going to be able to create a class, but here we are, and it's just really exciting. And I love teaching people about climate change. I'm just a high passion of mine, so I'm just very excited to be working with them on that. And then the planetary boundary layer, is my capstone project. As a senior, we have to do capstone projects, but I'm starting mine a little bit early. And it's basically looking at the planetary boundary layer, which is, if this is like the surface of the planet, the boundary layer would be like up here. And it's the part of the atmosphere that's influenced by stuff that's happening at the surface. So it's not too big, maybe about like 10 kilometers, like 8 to 10 kilometers about. And what we're looking for is to see if there's any difference in it's called the PBL, is what it's hyphened to, over ocean eddies, which are just swirling masses of water in the ocean, is like the best way that I could probably describe that to you guys. But yeah, they're both amazing projects. I'm very lucky to be working on both of them.
Well, that sounds really cool. I had never heard of an eddy before, so that's interesting. A new term for me.
Yeah, they're really pretty. If you like look them up, they're amazing.
I'm going to look it up right after this. So you're obviously very busy doing all of these this research, and you're Open. Give us a day working on one or both of your projects. What does your day-to-day look like?
So my days usually start around 8 a.m. because I've got classes. So most of my day will be like going to class, and then I'll maybe have 2 hours after class in which I'll work on the planetary boundary layer project, because I don't really need to be meeting with anyone to do that. It's kind of on my own for gathering the data and such. And then I might have another class, or I might go home and eat or something. And then for the ELM lab, we basically have meetings once a week for about an hour. So that's when I get most of the ELM stuff done, is just within that hour a week. And sometimes I'll have a meeting with One Planet over Zoom. That'll be like an hour to 30 minutes, about bi-weekly, so about once every 2 weeks. So other than that, it's just classes and homework, and then working on the projects when I have time in between.
So it's a lot of working with your computer. Is that right? Like,
yes, it's a lot of coding and finding data sources, trying to figure out how to get the information I need from those sources. That's definitely more for the planetary boundary layer project.
Yeah.
We do have other people in our lab working with that kind of stuff for carbon sequestration, but I am more outreach and working with open for
Got it.
carbon sequestration.
Sure. Yeah, that makes sense. Which is, I mean, coding is difficult work, but it's nice because you can do it wherever you are. You don't have to go to a lab, and you can do it at
Yes,
home. You
that
can
is a plus side of coding on
Yes.
your laptop. You can do it wherever.
Yeah, it follows you. So these are very
Yes.
specific interests that you've developed. Was there a defining moment in your life when you realized that you had a passion for oceanic sciences?
So I actually started out from a young age wanting to study weather. I grew up in a place that had very extreme weather, lots of hurricanes, tornado warnings, severe thunderstorms, and I just fell in love with it. There was nothing else I found more entertaining than watching lightning in the sky when I was little. I was a really weird kid, which nothing wrong with that. If you're the nerdy kid, that was me. I loved it. Nothing wrong with that. But that's how I knew I wanted to go into atmospheric sciences. And when I was in high school, I took an environmental sciences course, and we kind of learned more about the ocean and climate change and what is happening to our planet. And I was like, I need to work on this. This is something that I need to study. Like, I can't believe that like this is happening. And I immediately was like kind of changing my course a little bit to be like, I want to study atmospheric and oceanic sciences. I want to include the ocean part of it as well, because that's a huge part of climate change that not a lot of people necessarily realize and connect right away.
Definitely. So it really started, the seed was planted with lightning at a very young age, and then it kind of developed.
Yes. Yeah, I like always knew I wanted to be a meteorologist. Like in elementary school, they're like, what do you want to do? And I was like, I want to study weather. So
tell us about some exciting findings that you've come across in your research. I know research isn't always exciting. It's sometimes very mundane and you're in the weeds a little bit, but is there anything
yeah.
cool that you can tell us?
So there's nothing like too exciting yet with my planetary boundary layer project. I just started that about a month ago, really getting into the code. It takes about a month or so to get the background information. So research is a very slow process. Background information is very important. So I've gotten some results, but nothing that I'm too 100% sure on yet. So I don't want to lead anybody astray.
Yeah, sure.
But for carbon sequestration, it's kind of just supporting facts that we already know, but it's very exciting to see in results. For example, we did I guess an outing where we taped our sensors to our cars, and we drove around the DC Beltway to see where air pollution would be the worst. And it's very interesting to see that when you're around vegetation, it's not as bad as when you're just car traffic backed up. There's nothing there to kind of take in that carbon. So it really just supported that, yes, vegetation does help with carbon capture, and the same with the opposite and not
yeah, absolutely. Well, it must have been so
that.
cool to see that in real time. That must have been a cool
Yes, it
opportunity.
was. Yeah, I wasn't driving, so I had the sensor reader in my hand. It's an app. It's actually a website on your phone. Like, it's really cool.
Oh, wow.
And it just tracks. So like when we would drive by a forest, it would like go down, and then we would not, and it would go up, and it was just really cool to see that.
Absolutely.
We've also got some of those on campus too. So it's really interesting to see throughout a typical day when air pollution is going to be bad versus when it's going to be better. When the commuters come in, typically you see an increase. And then during the night, like after 5, when everybody leaves, it's not that bad. So it's just really cool to see that, because you learn about it in class, but seeing the results is just something completely different.
Absolutely. Yeah, absolutely. That's really cool. And finally, you're a young person in this field and incredibly accomplished.
Yes.
So how
thank
do you
you.
have any advice for other young people, particularly women who are interested in a similar field to you?
Yeah, so honestly, my biggest piece of advice is going to be to stick with it. It can be very, very challenging at times. It's not going to be the easiest path that you can take for sure. But if you find that you love what you're doing, stick with it. It's going to be completely worth it in the end. Get involved at your schools, or if there's other societies that you can join, get involved, network with people. That's very, very important. Make friends. The friends I have in my department have made it so much more fun to kind of be here, and they make the research more interesting, and they'll help you with the research. So it's just so, so important to like meet people, and you can talk about your interests with them. And it's just really, really amazing, especially other women in the field. I'm pretty lucky. My department is pretty 50-50, but I know there's some STEM fields where women are the minority, and that's amazing. Like, you have to represent, you have to stick with it. You have to just prove to yourself that you can do it, and that it doesn't matter that what gender you are. Like, you can do it. It shouldn't matter. And I just think that that's the most important is just to stick with it. If you find that you love it, if you find that you don't love it, it is okay to make a change. That is also very, very important. Even if it means switching outside of STEM, like if STEM is not for you, don't pressure yourself into doing it.
Right.
I like to say, follow your passions.
Yeah, definitely.
Because that's what I did. That's what most people in my department are doing. Like, you follow your passions, and it'll lead to amazing opportunities.
Well, that's some great advice. I encourage everyone to follow that. And thank you so much for sharing your insight and your work. We'll keep up with your work on Open, and look forward to hearing more from you.
Thank you so much.